In this video, we're going to talk about different types of functions. This is a pretty short video. The main idea here is that you are able to, or that you would be able to identify what are called parent functions based on a given equation. So what we see in this image, we're going to call parent functions. And by parent functions, we just mean kind of the beginning or most basic version of different types of functions. So we're just going to go through these. The identity function, sometimes this is called a linear function, and we can see an example of a linear function as something like this, y equals 3x plus 5, let's say. So what you're going to need to be able to do is recognize when we have a linear function, the parent function is equal to y, or is the same as y equals x. Similarly, y equals x squared, an example of a function that has x squared as its parent function would be something like this. The square root function, we could say y equals, how about 1/2 square root x plus 5. The cubing function, how about y equals 3x minus 2 cubed. Okay, so again, we would see any of these example functions and need to understand or be able to identify what its parent function is. The cube root function, an example of a cube root function would be x plus 2, let's say minus 1. The reciprocal function, we could have something like this, y equals 5 over x minus 2, and then an example of an absolute value function, maybe something like y equals negative 1/2 3x minus 1 plus 2. Okay, so in each of these, we would need to be able to take the given example function and identify each of these parent functions. All right, moving on. Now what we have here is called a piecewise function. Piecewise. And this is called a piecewise function because it has two different pieces. Okay, so how this works is the function is defined based on what the input is. And each of these things right here, x less than or equal to negative 1, x greater than negative 1, these are the rules for this piecewise function. So depending on what the input is, that will determine which rule we follow, and then we use the different parts of the function to evaluate. So let's do a couple of these examples here. So f of 0. Now the input is 0, so what we need to do is look at each of the rules. Now because 0 applies to this rule, the second one here, because 0 is greater than negative 1, what that tells us is we put the 0 in this part of the function. So what we're going to do is we're going to say 2 times 0, and that is equal to 0. So in this function we would say f of 0 is equal to 0. Okay, the second one here we have f of negative 1. Well, f of negative 1, that's going to follow the second rule because negative 1 is less than or equal to negative 1. That is true. Now it doesn't work in the second rule because negative 1 is not greater than negative 1. Alright, so because it follows the first rule, we input the value negative 1 into the first part of the function. So, we have negative 1 squared, and that is equal to 1. Alright, and then the third one, we have f of negative 2. Negative 2 is again going to follow this first rule because negative 2 is less than or equal to negative 1. That is true. It does not follow the second rule because negative 2, if we say that that's greater than negative 1, that is not true. So we're going to follow this first portion here. So what we say is that negative 2 squared is equal to 4. So again, when we are solving or evaluating a piecewise function, what we do is look at the rule, and then based on what the rule is telling us, that tells us what part of the function we're going to follow. Now here we're given a piecewise function as a graph, and we need to come up with the actual rules and restrictions for this function. So this function is named g of x, so we're going to say g of x is equal to, and then we're going to have some rules here. So let's look at this piece of the graph down here. Now what we have is this is going along the x-axis from negative infinity up to positive 2. So how we would express this as an inequality is x is less than or equal to negative 2, and we need to come up with a function that is representing this straight line. So one way to do this would be to write the equation of the line using these 2 points. So negative 2, 1, and then negative 3, 0. So if we come up with the slope, we're going to say y2 minus y1 over x2, x2 minus x1. We end up with negative 1 over, that's negative 3 plus 2, negative 1, so that's equal to 1. So that's our slope. And then we need to come up with the y-intercept, or we can use the point-slope form of the equation. So let's use this point and this slope. We're going to say y minus y1, so y minus 0 equals the slope, x minus negative 3. We get y equals 1x plus 3. So y equals x plus 3 here. So the rule that we're going to use is x plus 3 and x is less than or equal to negative 2. So we'd say x plus 3, and that is going to apply when x is less than or equal to negative 2. Okay, and then let's look at this piece up here. Now in this piece, what we have is we're going to start at negative 2, but we're not going to include negative 2, and we're continuing on to the right up until 1, and we're going to include 1. So if we were to write this as an inequality, we'd say from negative 2 up to x up to and including positive 1. Now, what is an equation for this? Well, because this is a straight or a perfectly horizontal line and it's going through y equals 4, this is just, if we were to write the equation of this line, that would just be y equals 4. So this is value of the function is always going to be 4. So anytime we put in some value into the function that is between negative 2 and 1, we're going to get a value of 4. And then for this final piece of the function, well, we are starting at 1, and we're not going to include 1 because we included 1 up here in the middle piece of the function. So we don't need to also include 1 here. It can't overlap. So from 1 to infinity, so we would say x is greater than 1 here. And then similarly, we need to come up with an equation of this line. So we can use these 2 points, 1, 4, and 2, 0. So our slope is going to be 0 minus 4 over 2 minus 1. We get negative 4 over 1, which is negative 4. Let's use this point. So y minus y sub 1 equals the slope, x minus the x point. We get y equals negative 4x plus 8 here. So that would be the portion of the function that we're going to obey here. All right, so anytime we input a value that is greater than 1, we're going to follow this rule.